Very much. Before going to the two presentations, I will just give a brief overview about Spintronics and its challenges. So I will just share my screen with.
Si tu cliques sur partager l'écran, la flèche verte en bas, et tu choisis ce que tu veux partager.
I do not see my presentation. And yeah, I'm Lucian Preșbeanu. I'm working in Spintech, a research lab which is dedicated in Spintronics. I'm just giving 2 or 3 minutes before of introduction. As you saw from the beginning of this day, there is a huge interest for developing smart systems for interconnected objects. For that, of course, there are new energy constraints in operation and standby modes, which are either linked to devices that have to be switched in sleep mode and woke up on events, need to store large amount of data in standby low power supply. Spintronics can bring that. So Spintronics is used of the spin of the electrons in some nanostructures, and there are some applications that evolved in the recent years that gave rise to this spin electronics field, with namely giant magnetic resistance, with some application in the field of magnetic memories, read heads, and sensor. For example, in the terms of IoT, we recently had a European project in which we combined several functionalities of Spintronic devices, in which we replace some IoT properties like sensing part, a storage part, and a communication part with either a magnetic sensor, a wake-up receiver based on Spintronic applications, or a hybrid CMOS MTG Spintronic low-power microcontroller. All this can have a positive impact on the power consumption. Now, of course, there are some concerns, namely in terms of materials, that the NEED project want to address. So the Spintronic stacks contain several materials which can be either complex to process, but also can be among the scarcest on Earth, and remain an obstacle to the wide diffusion of the devices. So in the framework of the project and the presentations that will follow just after, we'll try to identify solution to substitute noble metals used today in magnetic stacks for their unique properties by semi-noble metals. There were other studies in which 2D materials were investigated, and they are not covered in the presentation today. So there is also presentation from Justine Martin on sustainable nanoelectronic supply chain management, and afterwards Alvaro Palomino Lopez from Spintech will give details about scalable Spintronic devices which reduce platinum and ruthenium content. So that's all on my side. We are moving now to the presentations. So the first one is Justine Marty on this consumers integration for a sustainable nanoelectronic supply chain management. Justine.
Yeah, thank you, Lucian. I hope everyone can hear me well. I'm gonna start my presentation now. Okay. Can you see well the presentation?
Very well, thank you very much.
Okay, thank you. So I'm Justine Marty. I'm supervised by Blandine Ageron and Ludivine Chazmagnon. I'm working in the laboratory CERAG, and I'm financed by the IDEX from University Grenoble-Alpes. today I'm going to present you my PhD progress, and it's about integration of customers, consumers, users to develop a more sustainable supply chain management in the IoT field. So first of all, for the table of contents, for the first part, I will present the PhD, so the introduction, the areas of research, the structures of the PhD, and the progress. And then in the second part, I will show you the different articles that will be present in my PhD. Because my PhD is based on articles, so it means that the PhD is filled with 3 articles that aim to respond to the question of integration of downstream actors. So first of all, we already talked about that a little bit, but as you may now understand, we are 8 PhD students in a cross-disciplinary project, which is NEED for IoT. All the PhD are related to sustainability and IoT. We are 2 PhD students in social and human science, and the other are in fundamental and applied science. The objective of this group's work is to build cross-disciplinary knowledge and also to share some technological and social and human science knowledge. So the PhD subject is about the integration of customer, consumer, user to develop more sustainable supply chain management in the IoT field. So first of all, I think it's important to describe the difference between customer, consumer, and user. So for example, a customer is normally a company that will buy a product to then resell it just like that, or to process it and sell it again. It's not for his own use. The consumer is someone who's gonna buy a product to his own goods. And a user, some people say in the literature that it's a person that uses a product, but it didn't buy the products. For example, if your father has an iPhone and is not using it anymore and he give it to you, you are the user of an iPhone and on Apple brand, but you didn't buy it. But your father who bought this iPhone is the consumer. And Apple is the customer of, for example, ST Microelectronics. So just for a little understanding. So why are we studying this? It's because there are more and more connected objects, and there is a need for technologies, including rare metal, rare earths, and critical metal. There is a little literature on the supply chain of rare metals and on the supply chain of those. And it's clear that the supply chain of these materials is unsustainable, and that the consumer is not really integrated into the supply chain process. So for the areas of research that is interesting in my PhD, it's first of all to compare consumer and customer integration practice in B2B. So B2B means business to business within a sustainable context. So business to business means a company who works with another company. As we said before, it's, for example, ST Microelectronics who works with Apple, for example. And Apple is a company who works in B2C, business to consumer, because it works and sells product to you, the final consumer. So the next objective is to identify the different roles of consumers and customers regarding sustainable product in order to propose a sustainable supply chain management of the Internet of Things. And the main objective of the PhD at the end is to propose a set of tools, methods, and schemes to integrate consumer user in the sustainable supply chain management of IoT. So the question is why it's important to integrate the customer, consumer, and user into IoT supply chain. It's first of all, in order to propose a more sustainable supply chain. So as other PhD students shows, there is two ways to respond to the problematics of critical materials. It's first of all substitution, or then reduction if it's not possible to substitute them. And then maybe to propose a more ecological and ethical design, production and distribution method. It's not only the raw materials that is problematic. There is also issue during the design phase, the production and distribution method, and so on. So it's an important point in supply chain management. The second important point is to create products that meet and integrate the need of consumer. Because today, IoT are really technical. There is numerous specificities and product performance. Like, for example, you have an iPhone that have more MRAM than your computer, your old computer. You have, for example, 8 gigabyte of giga of RAM in your phone, but in your old computer you have only 4. So your iPhone is maybe more powerful than your computer, but you only use for texting and social media. So maybe there is an issue of adequacy between specificities and real or perceived usefulness. So the second point is how to integrate consumer, customers, and users into the IoT of the IoT supply chain. So now I'm starting to observe the current methods and tools that are present in other sectors of activities and even in supply chain management. And we want to extend this method to our field and even upstream, like for the upstream phases like production and design. So as I told you, my PhD is based on different articles. There is only 3 articles that will be in the PhD and other that I'm working on that won't be in the PhD. So the first one is consumer user customer integration in supply chain management, a review and bibliometric analysis. So it's a bibliometric analysis, meaning we are studying what is done in the field of research. And the second article is also a bibliometric analysis, but this one is focusing on the method of integration, and the first one is the whole concept of integration. And the third one is with Martin Christopher, who is a researcher in the field of supply chain management, and it's more on the field, so it's the title will maybe change a bit, but it's making supply chain management more sustainable, integration of consumer and customer and user in company using rare metals. So this article is based on interviews that we did also in companies, but also with consumer and users. There is also few articles that won't be in the PhD, the one of customer integration methods, but not in the supply chain management field. It's in the old field of management. And there is an article, work in progress with Pablo Manglian for the conversation. It's a definition for rare metals. And then an article with Alvaro Palomino Lopez that he will talk about it in this next presentation. So I won't dig too much in this topic. So first of all, the 2 first articles, which are bibliometric studies, are aimed to studying the literature review on the integration of downstream actors. We are focusing mainly on consumer, user, and customer. The objective is to discover the most influential authors, journals, years of publication, and things like that. The next step is to do a citation analysis, co-citation analysis, and cluster analysis. For that, we use 2 different software. We use BibExcel for statistics because we have a lot of statistics. For example, what are the most keywords used, the most authors cited, and things like that. And then we have co-citation analysis. And for that, we're using Gephi, which is a software for visualization. As you can see on my screen, there is a picture, and this is the final aim that we have at the end of the analysis on Gephi. So you can understand that, for example, the orange would be an areas of different method of integration. The blue one is another one, the pink one also. And all these big areas are talking together, and the aim of the article is to find what are the big areas and how they are connected to each other, what are the key points. So that's for the two main first article. Okay, so also the main result of this article is the link between the theme and the method. So we find 4 different themes. So the first one is collaboration. We have quality, we have sustainability and risk. And we were able to find what are the appropriate methods for each theme. So for example, for collaboration, you have CRM, which is customer relationship management. There is also the method of lead user. For the risk, you have collaborative forecasting, collaborative planning. For quality, you have voice of customer method, quality function deployment. And for sustainability, you have living lab or imperative structural modeling. In the article, we also tell that some methods are used for different purpose and that can be used to respond to this 4 theme and 4 different challenge. And now we can move on for the third article, which is on the field. So it's making supply chain management more sustainable, integration of customer, consumer, and user in company. So the objective is to observe the practice in terms of integration of the downstream actors in the supply chain of nanoelectronics companies, and also to see the consumer perception. So before doing our interviews, we did preliminary work like interviews guide with 3 main themes, with sustainability, metals and materials, and the third one is actors and integration. We also did a mind map with the key point that addresses like the same as the interview guides. And then we studied all the website of the different companies that will be interviewed for triangulation, to have a better view of that we will have in the interviews. So for that, we did telephones interviews and video conference interviews. We weren't able to go on site due to the pandemic. So it's one of the limitation of this article. And all the interviews were then retranscribed in NVivo software for qualitative analysis. And then we had a results analysis. So for the part of consumer result, for the 3 main themes, we have a really important, the sustainability is really important for the consumer. For them, the key point is to help future generation, and 90% of them thinks that it's really important, and they put action in place to respond to this issue. For the rare metals, which is the interesting part, is that there is a really limited knowledge. So we speak a lot about that, but actually normal consumer doesn't know a lot of things about these topics. They all know that it's because it's rare, maybe because it's in the name. And some of them know that it's linked to forced labor or child labor, but not that much of the interviewees spoke about the environmental impact and things like that, so, and geopolitical issues. But they all proposed that to respond to this issue, we could maybe substitute the product or reject it. So it's really good to have this information from the field. And then they propose really interesting methods such as use of expert, competition, brainstorming, help against payments. So so that's some methods that we saw on the literature review. And the final result, which is important in this article, is this map. We decided to put all the methods that we find from the interviewees. So some from the consumer interview and some from the company interview. And there is methods for integrating consumer and methods for integrating customers. So you can see the two lines is for the importance of sustainability and the importance of integration. For example, Living Lab, it's a method that is used to propose more sustainable product, and that's a high importance of integration. A website is not really a way of integrating someone, it's more sharing information. And for example, depending on who is targeted, the importance of sustainability is less important. So to conclude, this PhD aimed to contribute to the theoretical point of view. So it's bibliometric article, it's enhance the existing literature, identifying and integration methods, link between methods and their uses and the challenges. For the managerial part, it's provide company with a range of methods and tools and propose methods according to the expectation and challenge. The main limits are little explore subject, limited literature on some themes, and no possibility to go on field. And there is also a base of subjectivity constructivism approach in my analysis of the interviews. And I think I have a message. Okay, I'm supposed to finish soon. So the further work is to submit the first and the second article, finalize my third article and all the ongoing project. And the PhD core is currently in progress of writing. So it's the main objective for the final few months. And then research perspective, it's observing these methods in the field, testing in companies the methods, and also focus on consumer and users practice. So thank you very much. And if you have any question, I'm here.
Thank you for the very interesting presentation, Justine. So there is a remark from Jean-Pierre saying that it was a very interesting presentation that did analyze the relationship between customers, consumers, and users. And there is a question which is a more general one, related to how the IoT specifically is linked, why IoT are of importance for customers, consumers, users. And the comment is, to his point of view, IoT is a new market to keep high the sale of microelectronics products. What are the real needs for IoT? What are the benefits for IoT? So is IoT going to be designed to help the weakest of us or to serve the futility of the richest? So a complex question, but in general, why, how your study can be applied directly to IoT?
Okay, so it's depending what we put in IoT, but for example, from the interviews, some majority of consumers think that in IoT there is everything inside your iPhone, your computer, and it's really important for them. Some of them really know that it's a complicated situation, but they still want to have the abilities to change their phone every year, every 2 years, and some other things that it's time to drastically reduce. It was surprisingly that some, like half of the interviewers think it's time to stop this way of consumption, of consuming. So for, I think the benefits, there is always benefits in information system, and in IoT things, it's really important to say that. But maybe we are going too far, and some people really think it's important to stop what is not really suitable and useful for people. And for the last question, IoT going to be designed? I think it's a point of view. It's depend of your own point of view. From what I saw in the interview and my own belief, maybe for me it serves sometimes the richest and the futilities. We really need to refocus on what is important. But it's only my point of view. Maybe some people would disagree, and it will be totally normal. It's really depends of what people think and believes. I don't know if it's responding to the question.
Yeah, I think it's a complex question, and maybe there is a need for a more detailed discussion. I think Jean-Pierre is happy with that. There is a comment from Bernard Dieny saying that the name of rare earths is misleading because they are not so rare on the earth, and the main problem actually is mainly related to their purification involving some environmental constraints. My question was, because you mentioned rare metals, you included here only rare earths?
No, exactly. So it's a great. It's good that you bring up this theme, because it's all the work that we want to do with Pablo in our article of defining rare metals. Because for us, rare metals is the group, and within rare metals you have rare earths and critical metals, and from the interview is exactly that. People said the rare earths or rare metal are rare because it's in the name. But after that, after the interview, all of them explained the real issue with rare metals, which is more like environmental and criticality and ethical and things like that. But it's not the concentration. And that's why we want to write a little article in the conversation, just to explain to normal people the definition and try to make it easy. Because when you search on Google Scholar for literature review on rare metals or rare earths, it's directly really specific, and there is no like simple definition. I think in the domains, actually in supply chain management or things like that bring up the issues.
Yeah, there is a comment from Thomas complementing this, saying that rare is not mainly to how much we can find, but maybe related to their concentration and their impact on the mining region.
Yeah,
I have to. We have to move to the next presentation. Thank you very much, Justine, again for your very nice presentation. And now, Alvaro, it is yours.
Okay, hello. We'll try to show my screen first.
Yes.
I hope it works correctly. So you can see now my PowerPoint?
Yeah, I can see, and we can see your presentation.
Okay.
You can start.
Maybe I have to take this out. Yeah. Okay, perfect. So thank you. So as Luchan was saying in the introduction, Spintronic is expected to play a major role in the future of the IoT development. And so my thesis is focused on to try to solve the problem of materials that are contained in this type of technology. So in specifically focus on platinum substitution. So you might have seen that recently last year there has been a publication from the European Commission of an article that actually so wait, I will try to put the laser. Yes. So that try to identify which are the critical raw materials that are contained in strategic technologies and sectors for the European Union. And actually also in the European Union, there are several other projects that are related with the platinum substitution. So why there is the motivation for substituting this material? So it has been raised the question in the chat already that because of the high cost of platinum is one of the reasons. but also because of the high environmental impact that the production of this material has. So you can see here, for instance, in the graph, how the energy requirements for the production of platinum group metals that comprise platinum, but not only platinum, also palladium or ruthenium, it's very high, and it's quite higher than for other common or less common metals. So in this study that I just showed you here of the European Commission, they were addressing different sectors of information and communication technologies, and inside it also the memory technologies. So for memory technologies, they identify that platinum is contained in hard disk drives and also in ferroelectric RAM that Mohammad was speaking about before. But they did not actually identify platinum as contained in magnetic random access memory. That is that type of spintronic memory. And I will show you that actually it is contained. So just for you to have a little idea, so normally when we speak about memory, there are different components that they have different properties for the well functioning of the device. So there is, for instance, cache memory or main memory that are normally used there with SRAM or DRAM, and that they require power to retain the memory state. However, there is now well, emerging technologies as non-volatile memories, as ferroelectric RAM that Mohammad was mentioning before, or MRAM, that they are non-volatile, so meaning that they do not need power to retain their memory state, what is beneficial from this sense. And actually, to make a comment, he was mentioning that the ferroelectric RAM was very good in terms of retention, but actually MRAM has even higher retention capabilities. So it's expected really to play a very important role in the future. So just to show you a little bit how this type of memory works. So we have two magnetic layers that are separated by an oxide barrier, and depending on the orientation of the two magnetic layers, we can have a low resistance state or a high resistance state. So this is what will define the bit for the information storage. And as I was saying previously, in this study of the European Commission of last year, they did not identify the platinum to be contained in this MRAM, because they were addressing a type of MRAM that was used several years ago. So in this type of memory, they had an aluminum oxide barrier, and they were using an in-plane magnetized configuration. But nowadays, we use more often, or it's more extended to use perpendicular STT-MRAM because it has lower current requirements, and also it has better scalability to lower nodes. So a key point for this is to have a reference layer that you can see here in the sketch is not switching, so meaning that it has high thermal stability. And this is mainly provided by the cobalt platinum multilayers that are grown below the reference layer. So the only problem of this is that actually platinum is classified as critical material by the European Union, and it has a certainly high supply risk. So if we take a look on how these kind of assessments are made, so I think Lamia spoke a little bit about this already before, so I will not go very deep, but there are two main factors. One is economic importance, and the other one supply risk. So economic importance will depend mainly on how important is the technology in which platinum is contained. That will be, in this case, STT-MRAM. But then for supply risk, we have three main factors that define which is the supply risk of the material. One is the recycling rate of the material in the application itself, that we see that for electronic applications is very low. Then there is a Herfindahl-Hirschman index that has been also referred before, and gives you an idea of the concentration of the supplier of the material, and that for the case of platinum is mainly concentrated in South Africa and Russia. And finally, there is a substitution index that can decrease this supply risk, and this is exactly what I'm trying to do in my PhD. So find possible alternatives for the use of platinum in this technology. One will be based on perpendicular shape anisotropy, and second one based on building cobalt-nickel multilayers. So I will go for this cobalt-nickel multilayer alternative. So why nickel? Because as you see here in matrix, nickel is classified as non-critical material and has much lower supply risk. So, well, also has much smaller environmental impact. So this is another advantage as well. So there has been a lot of literature, well, a lot of advancements in the field of cobalt-nickel multilayers development. But actually, for the case of the synthetic antiferromagnet that needs to be used in MRAM, there has been not so many studies. And for what I've seen, normally they have difficulties of have a high switching field that will also define this retention that I was speaking before, this capability of have good thermal stability for the reference layer, so that not switch when switching the storage layer. And also, in some cases, they had some problems on going to high temperatures during the annealing process, what will be problematic for the CMOS compatibility that has been spoken also before. So we have tried to target these issues, and we start to focus first on the seed layer, because for growing these multi-layers, we need to have a very important 111 texture. And it has been seen previously that the effect of the seed layer that you can use, it is very important on the final magnetic properties of the multi-layers. So ourselves, we choose to go more for a copper seed layer material, because as well, copper is classified as non-critical. And it has the advantage that can also provide this 111 texture that we are looking for. So there has been some study evaluating which are what is the roughness that grows when having a thick copper buffer layer. And we did also this type of study and observed sufficiently low roughness for type of thickness of copper that will provide good 111 texture. So also we study a little bit the magnetic properties of such multilayers first, and we saw that after annealing, we were able to get even also much higher coercive field for these multilayers, which was positive results. So finally, we were able, after some more further development, to build the device based on cobalt nickel. So first I show you some thin film results at wafer level. And we saw that actually the magnetic properties of this synthetic antiferromagnet based on nickel were quite similar to the one based on cobalt platinum. And we see that the switching field occurs at very high field as well. And for the case after, we had to pattern this device in very small nodes. So here you can see we have pillars down to 20 nanometer diameter. And after doing the device itself and making the contact, we have some electrical results that are showing that the reference layer is stable, is not switching after applying magnetic field, but even after applying some voltage that will produce the spin transfer torque switch that is typically the writing mechanism of STT-MRAM. So also we have a low stray field and the stable state at zero field, which is required. So the only problem we had is actually that when doing annealing of this structure at 400 degrees, that is a typical temperature that is required for CMOS compatibility, the coercive field of these layers was very much decreased. And we started to find the reason of this and some possible solutions. So we observed that when having a capping layer of tantalum or copper, we did not observe this decrease of coercivity. And after we tried to find some solutions, and we made a double tantalum gather barrier, that this tantalum here is normally used as an absorber of the boron that will not migrate to the MgO barrier, but will be absorbed by the tantalum lamination. And so by making this double composite lamination, we have been able also to improve the annealing tolerance of the cobalt nickel SAF, and even at 400 degrees, the coercivity remained quite high. So even when comparing with the SAF made of cobalt platinum, we see that we still have very good properties. So just, okay, we have spoke about the possible alternative, but I guess it is important to evaluate what is the impact of really this platinum substitution in STT-MRAM itself. So here I just show you some numbers of the energy, the global warming potential, and the price that there is required for obtaining the platinum that is contained in the SAF structure. So this for thin film level. And then, so for a 300 millimeter wafer. Then I did the same for if we can have the nickel alternative. And as you can see, there is strong reductions in all terms: energy, global warming potential, and price. You can see this logarithmic scale. Even we are studying another alternative that is based on perpendicular shape anisotropy, and even with this other alternative, even if we use more amount of material because we have a thicker structure, at the end we also have reductions because we can have materials that are less environmentally harmful. But the point is that if we go to the big picture and we see which are the requirements for the silicon wafer production, and this goes in line with our previous question as well. So the requirements are relatively bigger, so that at the end, the substitution in these economical terms is not that important, I would say. So
Alvaro, just so you know, you have 1 minute left.
Okay, so because of these, some initiatives as the recycling of silicon can be important that we have seen recently in Leti. But well, this I just to show so the platinum thickness then that we will have to have in our wafer to have similar impact to the silicon wafer itself will be as high as 50 nanometer. That is not the case for STT-MRAM, where we use only 2.25 nanometer of platinum layer. So, but still there is the question of the supply risk that we have been discussing before. And the point is that the platinum production is very concentrated in these two countries, South Africa and Russia. And even the market is scoping, 80% of the market is scoped by 4 mining companies. So in order to try to find solution for these possible platinum supply disruptions that can happen, then a possible alternative as the one based on nickel can be very important and really can let us to avoid some geopolitical conflicts, and then it is interesting. After also we have seen that we are using a copper seed layer, and this also is a type of material whose production is very diversified. If we compare, for example, with another material as hafnium that is also used for the cobalt nickel multilayers growth. So, well, here I will skip, just wanted to show you some results on the PSA development that we have been having, but there's not much time, so just go to directly to summary. So I've shown you that the cobalt nickel substitution, cobalt platinum substitution by cobalt nickel, it is a possible alternative for the SAF of the magnetic tunnel junction in STT-MRAM. That we have demonstrated that it is possible to have a good back-end offline compatibility for CMOS integration by protecting the cobalt nickel multilayers from some element diffusion like iron, and that actually the impact of this substitution can be not so high in terms of environmental impact, but there's still the question of supply risk that can be really mitigated by having these alternatives. And then also the other second alternative that we are trying to investigate as well, that is based on perpendicular shape anisotropy, that has also the added advantage that has no ruthenium in its structure. And with this, I will conclude, and I let you go to lunch.
No, there is still a conclusion, a general conclusion afterwards. Before maybe some questions. There are no questions for the moment in the chat. I don't know if someone wants to ask directly a question about Alvaro's presentation?
I have to stop
sharing. Yeah.
Yeah.
If not, I have this question related. You made an important conclusion, which I think is that, of course, replacing small amounts even of critical materials, so is about the criticality, that's important. But in terms of cost, silicon recycling is the most important part. You cited that study from Leti, which is maybe ongoing. Do you know if there are concrete actions which are taken?
I'm not aware yet about this. I think they started to do this recycling of the silicon that is used for research, but after I'm not sure even. I would like to know more about what's happening at the industrial level as well. Is there where actually is more silicon use. What I've seen is that after, for example, for the final devices that are fabricated, the main problem is that most of the final devices at the end, they don't end up in recycling facilities. So even if we have the possibility to make the recycling with a high recycling rate, the problem is also that we don't get the final products where they should be, and sometimes they even end up in other countries where they don't have these facilities to make the recycling properly, and so we lose a lot of capabilities there, I guess.
Understand. There is another question from Thierry Baron asking if cobalt can be also substituted, not only platinum.
So this is a bit more difficult in the sense that, well, actually in the alternative of using PSA that I was speaking about, it could be substituted because we could use a much more common material as permalloy, nickel iron. So because there we don't rely on the interfacial properties of cobalt and platinum or cobalt and nickel, but it's just a shape property. So just by elongating the magnetic pillar, we could have this effect with a much more common material as is permalloy. Okay. Then there are other alternatives, as you were saying at the beginning, like using 2D materials as graphene that has to be investigated, but it's still under development. Yeah.
Thank you very much. Before giving to Thierry, the General Chair, the final word, maybe just reading the proposal from Thomas Ernst. I'm also agreeing on this to give the best question and answer prize for Jean-Pierre Raskin, professor. Okay, thank you very much. And Jean-Pierre is thanking all the presenters, speakers, and Thierry, is your turn.
I'm online, so I think we can conclude. So I want to thank all the speakers for the presentation, which are very clear and which show a broad aspect of the NEED project, growing from technological advances to social, ethical, and environmental aspects. So thanks for all. I want also to make a special dédicace and special thanks and thought to Audrey Dieudonné, who helped us to build this webinar and to manage the NEED project. But unfortunately, she cannot attend the meeting today. And for the final word, I want to give the mic to Thomas Ernst. So if you want to conclude this this webinar on the NEED project.
Okay. Can you hear me?
Yeah.
Okay. So thank you everybody, especially the PhD students that make a great effort. I think the presentation were very clear, and we know that this time is not very easy for PhD students how to make their research, access to the lab, etc. And I think in the NEED projects are very dynamic, very involved in their work, and they succeed in making very relevant research, I think, even very specialized research. but taking into account environmental impact. And I think this is the future for many of our topics. And they are really, I think, pioneering these new fields. And I want to thank also all the labs that in University Grenoble-Alpes are part of this project. And it was not easy a few years ago to push this topic. And I think all of you and also the lab director and researcher were very involved to make this possible. And I think that now we see that more and more projects are take into account this aspect, and I think this is the future, especially that material maybe will be the next black gold of the 21st century, because they are at the base of all the ecological new technology for energy, for electronics, etc. So we have really to continue to have this global approach that take into account both technical disruption problem and also keep this general view of the impact of what we are doing. So, and this will be required, I think, more and more by the funding agencies and the government also. So I think we have to continue this effort and to continue this sort of club around the NEED project and the international collaboration also. And I think I thank a lot Jean-Pierre, because he was also at the beginning with us, pushing initiative in Université Catholique de Louvain, many great initiatives there. And we share our experience with him, and this is why he was, I think, so active in this workshop. And I thank also Jean-Pierre for the very good collaboration we have together. Thank you, everybody.
Okay, thank you, Thomas, and I want also to thank Lucian and Ahmad for help us for the chairing the session. Thank you also to all the attendees. And I have normally stored the workshop. So if I succeed in saving it, I will probably put it online. So thank you very much, and have a nice day. Thanks. Bye-bye.
Thank you.
Bye-bye.
Bye.
Bye.